Okay, our new topic is quadratic algebra. So before, when we were doing linear means it is a straight line. So we saw all straight lines. When you think about our linear equations, so we might have had x plus 2 or something, the highest power on the x was always a 1. Now that we're doing quadratics, so a quadratic, later on you might see a quadratic graph. A quadratic graph is like a curved graph, and when you see its equation, it has the highest power in it. Say this is an example, it will be a squared term. So a quadratic will have a squared term in its rule. Okay, the first thing that we're going to do when looking at quadratics is we're going to remember our factorization patterns. And we've done a couple of these way back when we did expanding and factorizing. So we're really revising this, but let's have a look. So we have one pattern that's called the difference of two squares. So you can see that that negative means the difference, and we can see two squared terms. Now we know when we see this is expanded form, the a squared minus b squared, and we know it can be factorized. When you factorize it, it always factorizes to a plus b, a minus b. So we worked the other way. We saw this form and we knew that it expanded back out to that way. So in these examples, factorize each of the following expressions. So for this first one, we can see it is a difference of perfect squares because we've got x squared, and we could write 9 as 3 squared. Once we know that, we should recognize the pattern, and we know that it factorizes to x plus 3 and x minus 3. Okay, if we look at this next one, we can see that 64m squared. So 64 is actually 8 squared, so I could write this as 8m squared like that, and I could write the 25 as 5n squared. So now we have a squared term minus another squared term. We know that factorizes to the first term plus the second term is one factor, and then the second factor is the first term minus the second term, like that. Okay, with this last one, it doesn't matter, this is still a squared term here. It's just got a bracket. Now if I write that one, I can write 16 as a squared term, which is 4 squared. So I have a squared term minus a squared term. So we know that factorizes out to the first term, and one time we add the second, and the second time we minus it. Now because we can add 7 and 4, we'll do that. So we get 7 plus c plus 11 is one factor, and then we get c plus 3 is the other factor. Okay, if you remember when we were factorizing way back, remember we always said the first thing we should do is, if we can, take out a common factor. So if you look here at this one, we can see that 3 is a common factor. So if I take out 3 first, I'd be left with x squared minus 16, because 3 times 16 is 48. And then we can see we've got a squared term minus another squared term. So inside those brackets, I can factorize them to be x plus 4 and x minus 3. So if I had to factorize this expression up here, here is my answer. Okay, a bit later on you'll complete exercise 16.2 and questions 1 to 4, but we're going to go on and look at another expansion pattern. So if we look at these perfect square rules now, so we had, this is the factorized form, and this is the expanded form. So these are quadratics because we've got the squared there. So we went from the factorized form to the expanded form, and we knew that when we saw a plus b in brackets squared, that it always expanded out to a squared plus 2ab plus b squared. And if it was the same thing but minus, we saw just this minus up here. Okay, so now what we're going to do is we have to be able to see that pattern when it's in its expanded form. So what we're going to look at, if we look at this first example, so it says factorize each of the following expressions. We've got x squared minus 3x plus 9. So remember what we did. First we look, can we make the last term a squared term? And we can. So remember it was one of the patterns. And then we look at the middle term. Is the middle term 2 times those squared terms? Which it is, because 2 times x times 3 gives that 6x. So once you've worked out that it is one of those patterns, we can see that this is the same as saying a squared minus 2 times a times b plus b squared. So that's the same as that pattern. We can then factorize that expression, and we know that that would factorize down to x minus, because there's a minus here, 3 squared. Okay, so let's look at b. So our first thing is to do n squared. Let's see, can we make the last term, this term, a squared term? Which we can. It's 10 squared. Now, is the middle term, is it 2 times the other squared terms? Which it is, because 2 times n times 10 is 20n. So therefore we can say that it's n plus 10 squared, because it fits one of the patterns. Okay, here we're going to do a couple more examples. So we're going to look, we look for a squared term, so we can see that 64 is 8. We could write that one as 8 squared. I'm just going to leave this 80am. But this last one could be written as 5n squared, like that. So to see if it's one of the patterns, we should see, does this middle term, is this middle term 2 times the first squared term times the second squared term? Which it is, isn't it? Because 2 times 8m, 16m times 5n is 80mn. So we can see, yes, it's one of the patterns. So therefore, when I factorize this, it must be 8m, and because there's a plus there, plus 5n squared. Okay, now looking at this one, we have to be really careful. Always check. We should be checking, is there a common factor? Which there is here. It is 3. So we should take that out first. So we'll take 3 out and we're left with x squared minus 8x plus 16. So this, we've taken the common factor out. Now we might just look inside this other bracket, because we can see that 16 can be changed to 4 squared. So therefore, is that middle term, is it 2 times the first squared term times the second term squared? So it is. So we can, because 2x times 4 is 8x, so we can factorize that square brackets in here to be x minus, because there's a minus here, 4 squared. Okay, and now you're going to go off and do 16.2, and you can do the previous questions that I mentioned, and also question 5.